So today we're going to talk about transformation in statistical measures. Here's the table of contents. In transformation, we're going to talk about rotation, enlargement, and combined transformation. In statistics, statistical measures, we're going to talk about range, which average you use, and the stem and leaf diagram. First, we're going to talk about rotation. So what is rotation? Rotation transforms a shape to a new position by turning it around a fixed point. It is always be given three things to construct a rotation: the center of rotation, the rotation degree, and the direction of turn. So sometimes the center of rotation is given on a scale, but sometimes it is given in the form of number. For example, here it is given the center of rotation, but here rotate the given shape 90 degrees clockwise about 4,5. So that means 90 degrees is the rotation degree, clockwise is the direction of turn, and 4,5 is the center of rotation. How to do the rotation? You need to do rotation by using the tracing paper. There's a method to do rotation without using it, but it's much more difficult, so I recommend you all to use the tracing paper. Step 1. Draw the shape that you wish to rotate onto the tracing paper and put this over the shape, like this. Next, you push the end of your pencil down onto tracing paper where the center of rotation is, and then turn the tracing paper through the appropriate angle. Step 3. The resultant position of the shape on the tracing paper is where the shape is rotated to. You just need to copy the shape down. Sometimes they ask us to draw to construct the rotation, but sometimes they don't. They're gonna ask us about the center of rotation. So to begin, you're gonna take the three segments that connect the three image points to the image points. So in this case, you can see that they will connect the point A to point A, comma, point B to point B, comma, and point C to point C, comma. So then you're gonna construct the perpendicular bisector of each line, and where that line intersects, that is the center of rotation.
So now we're gonna talk about another way of transformation, which is enlargement. So defining the term of enlargement is just changing the size of an original shape or diagram to give a similar image by x times. This x number is called a scale factor, and to enlarge a shape, a center of enlargement is required. The problem asks you to construct the enlargement. The question will give you the center of enlargement. When a shape is enlarged, the distance from the center to each point are multiplied by the scale factor. So there are two main ways to construct an enlargement. The first way I'm going to talk about is the ray method, which this is the only method that will be used if you have to construct a diagram which is not on the grid. So step 1, with a ruler, a straight line from the center of enlargement, which in this example is the red dot, to each of the points on the object. So you're gonna draw 3 lines because this shape has 3 points. And again, using a ruler, you measure the distance from the center of enlargement to each point. So there are 3 lines here. We have to measure is the yellow line, the purple line, and the pink line, and it gives us these values. In step 3, you have to multiply the distance from step 2 by the scale factor. So in my example, the scale factor is 3, so each distance gonna be tripled, and you have to draw new lines from the center of enlargement, passing through each point on the object and continuing until they have the new length. You put a point at the end of each line to mark. And step 4, which is the final step, is to joining up the points at the end of the new lines from step 3, and these points are the vertices of the image. So the coordinate method is when you are constructing it on a grid diagram. So step 1, you would have to find the distance from the center of enlargement to a point on the object. So looking at my example, the center of enlargement is the red point in the middle of the square, and the distance to the corner of the square is 1 diagonal unit. Step 2, the distance to the equivalent point on the image is the original distance times the scale factor. The direction is same as in step 1. So in this example, my scale factor is 2. So you would take 1, which is the diagonal unit, and you multiply it by 2, which is the scale factor. So the new distance is double from the original distance. And then in step 3, you repeat step 1 and 2 for each of the point on the object, or at least you'll have enough points. And then you join those points together, and it will give you the enlargement of the shape. Negative enlargement. So negative enlargement is when the scale factor is negative. So as you could see here, the difference of negative enlargement and normal enlargement, which the scale factor is a number greater than 0, is that the lines when you draw for enlargement doesn't start from the center of enlargement anymore, but it passed through the center of enlargement, which gives you the shape here. And then you do the same same as the coordinate enlargement. So in this picture, you see our example, the scale factor is -1. So the shape is still the same, but it just shifts onto the other side. So what you will notice about negative enlargement is that the shape will be enlarged. For example, twice, it will be just twice the shape, twice the size of the original image, and the image will be inverted, which is upside down. Fractional enlargement. Fractional enlargement is when the scale factor is a fraction which is smaller than 1 and larger than 0. Here's an example. Normally in fractional enlargement, you will notice that the shape of enlargement will be smaller than the original image. And the way of finding the fractional enlargement is also the same as by the coordinate enlargement. So here in our example, the scale factor is 1/2. So a common question which is asked in the IGCSE exams is finding the center of enlargement. To find the center of enlargement, you connect the straight lines from each point on the image through its corresponding point on the object, and then the point where the lines intersect is the center of enlargement. So as you could see here, because this shape has 4 corresponding points, so there would be 4 lines has to intersect with each other, and their intersection is the center of enlargement.
So thirdly is combined transformation. Note, to describe translation, we use a vector. In this example, they ask us to translate by a vector of 8 and 4. So it means that we move this triangle 8 squares to the right and 4 squares up. To describe reflection, we use a mirror line. And to describe rotation, we need a center of rotation, a nature of rotation, and the direction of turn. And lastly, to describe enlargement, we need a center of enlargement and a scale factor. For example, 1. A. Triangle A is translated by a vector minus 1.5 minus 3 to give triangle B. Triangle B is an enlarged by a scale factor minus 2 about the origin to give triangle C. Draw triangle B and triangle C into a diagram. And B, describe fully the single transformation that maps the triangle C onto triangle A. And to translate triangle A by a vector of minus 1.5 and minus 3. So we have to move triangle A 1.5 squares to the left and 3 squares down. So we have triangle B. And then triangle B is enlarged by a scale factor minus 2 about the origin to the triangle C. So firstly, we have to remember that enlarged by a negative scale number is then the image will appear on the other side of the center of enlargement and will be assigned out. So firstly, we connect the corresponding line and by the scale factor, and we have to connect it to draw a triangle C. And B, describe fully the single transformation that maps triangle C onto triangle A. So to transformation that maps the triangle C onto triangle A is that enlarge C by a scale factor of minus 1 over 2, the center of 1, 2.